Alright, so in this video, I'll be reviewing my own design of Orion. So this was the board that was used, I think, last year and the year before for the ERC 2023 and 2024. So I'm making this video because there are quite a lot of new members and I don't really want people to just blindly trust what I did a few years back. So I'll be reviewing some of the modules and the PCB routing and critiquing some of the parts that I think should be changed or the parts that you should not refer to for new designs. Right, so let's get right into it. So first for the overall architecture, I think it's fine. But let's get a bit into the microcontroller side. So I'm just doing it a bit freestyle, so I don't have any script. So we just have a look at these. So these look okay. One thing that I would change is to not use an external flash memory. So this is with the QSPI bus. So we decided to use the STM32H750 simply because we had a lot of issues with sourcing, because this board was designed during the COVID era, and there were not during the COVID, but during the semiconductor shortage era. So there were a lot of things that we just couldn't order. The issue with this board is that it only has a very low amount of flash memory, so 128 kilobytes, and this, because of this, we had to use an external flash memory, which made the system more complex than necessary. So this is one thing that I would change for sure. The crystal and all of these is okay. For these ESD protection diodes, I might change them because I think that the clamping voltage is too high. So here you can see that the breakdown voltage is at 6.1 volts, and the clamping voltage can be quite high. Here it's around VCL. It clamps up to 10 or more, depending on 30 volts or more, depending on the pulse current. So this is not good, and you should definitely change that if you want to have any ESD protection that is suited to the design. So the ESD protection should be chosen according to the maximum voltage that the pins can accept. For the GTMS and all of these pins, you can simply go in the datasheet, and if you look at the pin definition, so let's just type in SWDIO. Here you can see that it's an FT pin, and the FT pins are 5 volts tolerant. So this means that we need, for this pin in particular, an ESD protection that can handle and clamp to 5 volts. So if you want to have better design for that, I recommend looking at the Amulet controller project. So this is also on GitHub in the legged robot repository. So in this design, I use the correct ESD protection device. So you can go in the interconnects part, and here you will see some of the ESD protection that I have chosen. Okay. These LEDs are okay. And this is for the power part. So I think that this switch here, it might be better to simply pull it to the correct voltage. So in the case of this design, we always want the switch to be towards the FM side, which is for the flash memory side. So this is what we want. So we want the pins number 2 and number 3 to be connected together. So if I had to redesign it, I would just short this to the ground, so we don't have any issues while flashing the board. So this is also okay. I think that if you want to reduce the cost, you could also omit these crystals so they are not very critical, and you could still make it work even with the internal oscillator. Then for these ferrites, I'm not sure if this ferrite is well suited or not. If you look at the impedance curve, it might be a bit, it might not filter the noise as you think it should filter. So this is something also to review if you want to make a new design. You could also completely omit this ferrite bit and it would still work quite well. Okay, let's go into the USB to UART bridge. So this part looks quite okay. So here we have a reverse protection circuit, ESD protection, and then we have here an LDO and the USB to UART transceiver. So this all looks fine, and I think you can keep it like that. Yeah, I think that looks okay. Then for the power connectors, here this is also okay. I might add a bypass capacitor near the power pins between the 5 volts, 3 volts, and ground in order to filter a bit of the input power. So you could just put something like this and then put this to ground. So this is just, yeah, just to filter things a bit more. Then for these power transceivers, something that I completely forgot to put, and you should put it, is some more bulk input capacitance. So right now, I think there is some that is missing. Let me just check the data sheet. So normally you should have capacitance on the V in and on the V out. And in this case, we have capacitance on the V in here and on the V out. Okay, no, maybe it's okay in this case. So here V out, here V in, so this is fine. And for this one, we have one here and one here. So yeah, I think it's okay. Yeah, it's not the best because here we have the 3 volts, which is coming this way, which is decoupling in some weird. Yeah, I think the routing here could be a bit better, but should be fine. Okay, so then for the E-fuse, you can keep it that way. I would remove this jumper here. It takes quite a lot of room and it was not used anyway, so. Okay, so this part is okay. These transceivers, I think it's also fine, so you shouldn't have to change anything. Yeah, so this was already corrected. I think in the video this was 4.7 microfarad, but it was correctly corrected last year to nanofarads. So these transceivers are also fine. This is for the QSPI flash memory, which I would remove if you change the microcontroller. Here I would completely remove these capacitors for the mounting holes. So normally you would just add a resistor or a 0 ohm resistor just short it to the ground in this case, and it should work okay. Okay, so for these I will also take a look at the ESD ratings. So these might be, I'm not sure if these are well suited for it or not. So I still recommend using the chips that I used on Amulet, which are these two, depending on the voltage, if it's 5 volts or 3.3 volts tolerant. Okay, so let's go quickly into the PCB layout. So there are quite a lot of things that I'm not really satisfied with. So first and the most important thing is the stack up. Currently this is a 4-layer board, and we have 2 layers, inner layers, with one for the ground and one for the power, and you can directly see a lot of issues there. So first, the ground layer has splits in it. So here you can see that the ground for the crystals was split, and the one for the electronics fuse was also split, and this is not very good because this will act as an antenna which could radiate, and this is not very nice. So if you want to have something that is a bit better, I would just remove these splits. For this in particular, I think that for the crystal it should be okay as long as there is no signal crossing that split. Here you can see that on the first layer we have no signal that crosses the split, so this is okay. So this is just to make sure that the return path, so here when you have a current that goes like that, we need to have a ground reference plane so that the energy can be contained within the dielectric space between the trace and the plane. Here for the electronics fuse, I would also remove the split because because this is not very good practice. So here you see that we have some weird short between the ground and the fuse ground. So this is not good, and I would completely remove these splits. For the power part here, I would, I think it's fine, but if you keep this power part, this power plane, I would add another layer between the inner ground, inner plane 2 here and the back plane. I would add a ground plane. So the best move for this board would be to move it to a 6-layer instead of a 4-layer, and to have signal like this, then have a full ground. Then you could have some signal if you want, but another ground is also fine. Then the power, then another ground plane, and then the back copper. Okay, so this is these are the biggest changes that I would make for this board. And otherwise, I think it looks quite okay. So here you can also see that I've placed vias near each signal. So this was as a way to add transfer vias so that the return path along the Z direction, so along the thickness of the board, can go through these vias. But the problem is with this stack up, with the power plane and the ground plane, because the power plane is not a very good reference plane at low frequencies and is a moderate one at high frequencies, it might not be very good to have these transfer vias with this stack up. I would add another ground plane as I explained earlier. So yeah, otherwise I think it looks okay, and you should be fine with that. If possible, I would also space some of the traces. So a lot of these traces are unnecessarily close to each other, and you can definitely space them to reduce some of the issues that you might encounter. And yeah, so that's it, I think. The rest of the board looks okay. So this is just a few minor corrections, but still important corrections, especially the stack up, and something that I would not use this board as a reference for new designs. So you're not you don't really have to reorder and correct this board because it works. But if you make something new, I don't really want you to take this as a reference with the split ground planes and the split power planes. So if you want a better reference, I strongly suggest looking at the amulet design, which is much more thought. So there's a lot more thought put into it, and you can see that there is no split in the ground plane. and all of the signals have their reference ground planes. So just as an example, if you take layer 4, you can see that the signal does a weird zigzag here. And this is because on the layer 3, we have the ground reference, which completely follows the signal. And this is done on both sides. So you can see that there is a reference ground plane for on both sides of each signal. And this is the best thing that you can do to maintain good signal quality. So yeah, just take a look at this board and don't look too much into the layout of this board. I think it's okay for most of it, but it's not perfect, of course. The schematic is fine though, so you could have a look at that for reference.